Hello, let's start on the next section for the heart. And it's a good starting picture. It shows many of the blood vessels that you will be able to identify at some point. You'll be able to identify all of these, not today, but we will go through some of them. And let's put this one in here too. You will be learning those, so pay attention, and you'll get it. Ask questions when you have them. So let's start with just the location of the heart. It's in a cavity, a subdivision of the thoracic cavity called the mediastinum. And the mediastinum is in the center of the thorax. So its anatomical boundaries start there. If this is the diaphragm, which it is, it's pointing to the brown, large, dome-shaped muscle, and the diaphragm separates the abdominal cavity from the thoracic cavity, sort of the inferior floor of the mediastinum, and the lungs are over here, and they form the medial wall. So this is the mediastinum that I'm drawing in green. And the lungs go off to the side, of course. But the medial portion, the medial boundaries, is bordered by the lungs. So this area that I'm hatching in is the mediastinum. And within the mediastinum are a number of structures, including the heart, of course, and the trachea and the esophagus. They all run through this mediastinum. And the aorta then passes out here also. But this is the subdivision of the thoracic cavity where the heart is located. And should probably note that this is an anterior view that you're looking at. So the front half of the rib cage has been removed, which would form the anterior border of the mediastinum. And the vertebrae, the vertebral column posteriorly form the posterior wall, which of course aren't shown either. So let's start in with the major structures of the heart. And what you need to learn are the chambers, the valves, and the great vessels that are connected to the heart, all of which is shown in this figure. So let's go through the chambers first. And color for contrast. The right atrium forms the upper chamber, and then the right ventricle. So that's the right side of the heart. There's a septum between the two, and then you have the left side of the heart, the left atrium, and the left ventricle. So those are the four chambers. Two atria are on top, and the two ventricles are below. For the vessels, the superior vena cava, we might abbreviate just to speed things up as SVC for superior vena cava, and the inferior vena cava we could do similarly, IVC, just speeds up our note taking. And so let's do the right side of the heart first for blood flow. And the blood returns to the heart through the vena cava, which is plural for vena cava. And let's go to a different color that shows up a little bit better. So this is just blood returning to the right side of the heart, the right atrium. It's referred to as the venous return. the venous blood returning back to the heart to go through the pump through the heart and the lungs again before it circulates. And then after that, the blood goes out, it goes into the right ventricle. There's a valve that we'll come back to, and then it gets pumped out of the right ventricle into the pulmonary trunk or the pulmonary artery. You can call it either one. And those then branch into the right and left pulmonary arteries. And this goes out to the lungs. Gets oxygenated at the lungs. Carbon dioxide is released, oxygen's picked up. The blood returns from the lungs to the left side of the heart. So the blood comes back from the lungs into the left side, the left atrium. There are holes there. And from the left atrium, it then flows into the left ventricle and ultimately out of the left ventricle under high pressure into the aorta. And then from the aorta, it branches and is distributed throughout the body. So that's the basic flow of the blood. You should be able to trace a drop of blood from when it returns to the right atrium through the different chambers in order. So right atrium, right ventricle, lungs, back to the left side, left atrium, left ventricle, back out through the aorta, and then you're done, tracing a drop of blood through the chambers of the heart. The valve, let's finish off the vessels. So we talked about the right side of the heart. We have the superior and inferior vena cava, and we talked about the pulmonary artery or the pulmonary trunk, and it goes to the lungs. So to the lungs are the pulmonary arteries, pulmonary arts, for arteries. Arteries carry blood away from the heart. Veins carry blood toward the heart. Don't think in terms of oxygen level, or it will get you goofed up in several places, the heart being the major one. Blood that returns from the lungs is returned to the right atrium through the pulmonary veins. They're veins coming back from the lungs to the heart. That's what makes them a vein, not the oxygen level. The valves that we need to pay attention to, well, let's go to another figure, the next one. That will be easier. So for the aorta, there's the ascending aorta, and ascending just for going up. And then there's the arch of aorta, where it just arches, goes back down. And then you have the descending aorta. And that part of the descending aorta that is in the thorax, the thoracic cavity, is referred to as the thoracic aorta. Once the thoracic aorta goes through the diaphragm into the abdomen, it's referred to as the abdominal aorta. But the thoracic aorta and the abdominal aorta are both considered descending aorta because it's going down inferiorly. So here's a cartoon drawing that I made up for practice. And you can just print this out and have several copies of it. It's also used in the heart dissection video that I made that's also posted in this module on Canvas. So let's go through this. Again, this is good practice. You should be able to whip up a Mickey Mouse heart. And when I say Mickey Mouse, I mean it because it kind of looks like this. I'm not going to record this. I'm going to erase it. So don't draw this in your notes. But I would often draw a heart like a Valentine heart. That works. Divide it up into 4 chambers. That's good. And you can identify right atrium, left atrium, right ventricle, left ventricle, etc. That works. And you could put in the valve, the Atrioventricular valve that we'll talk about. Diagram works okay for that. And you could put in the Vena Cava. Diagram works okay for that also. So don't draw this in your notes and take up your paper. But what I'm going to show you is what it doesn't work well for. So that would be the inferior vena cava and the superior vena cava. Everything's good now until you try, and you put in the what blood vessels am I drawing here? What are those blood vessels representing? You said pulmonary veins, good job. But what this type of a model it has trouble with is trying to now draw in the aorta, which is coming out of the left ventricle, and the pulmonary trunk, which is coming out of the right ventricle. And it doesn't make a lot of sense, I don't think, to draw them coming out here, because they don't. You know, that's misleading. So I switched from that model to doing this model, and you might try this. Here's the heart and the ventricles, the interventricular septum, and then the atria are out here, which is similar to like what I did on the left. And then you can use this type of a drawing to come and put in your atrioventricular valves, sort of a picture. And you can still go ahead and put in your pulmonary veins and your vena cava, etc. And then you can draw in the aorta and the pulmonary trunk coming out of the ventricles. So again, this is the right ventricle and the left ventricle, and the right ventricle pumps blood out through the pulmonary trunk. I'll just abbreviate it now for PT, out through a valve. Likewise, the left ventricle pumps blood out through the aorta. And there's our descending aorta. That's sort of a picture. So that's what I've done on the right, is that type of view. And I called it a Mickey Mouse view because it seemed to me it wouldn't be too much, just put some whiskers on it, you know, and there's the nose. And I don't know, the eyes would be up here somewhere. Don't put this in your notes. Right? Sort of looks like a mouse head. So I'm going to erase that and let's go back to the diagram on the right. Okay. So this would be the, you can say it to yourself, superior vena cava, inferior vena cava. And by the way, the diaphragm is running more or less like this. The heart is sitting right on the diaphragm, but it doesn't sit like a point right there. It's really sort of laid on the side. So that's the diaphragm. Abdominal cavity below, thoracic cavity above. So back to the heart. Right atrium and right ventricle. And this this would be the pulmonary trunk. Let's do a little key over on the right. So PT equals pulmonary trunk. I'm going to abbreviate pulmonary. I'll spell it out first time. Pulmonary trunk. And then it branches, this is arterial blood, into the right and left pulmonary arteries. So let's just abbreviate right and left. Pulmonary, I'll abbreviate pulmonary arteries, ARTS. Okay? And that's carrying deoxygenated blood to the lungs. We'll come back and do the valves last. So the blood goes to the lungs, and then it comes back from the lungs, oxygenated, through the pulmonary veins, and I'm going to write VV for plural of veins. So we'll make another little note over here in our key. V equals vein, and VV equals veins. So pulmonary veins. And these also are pulmonary veins. So this is our left atrium and our left ventricle. And then this would be, blood will flow out of the left ventricle into the aorta. So I wrote that on the arch. And then it descends. This would be the thoracic aorta, since it's still in the thoracic cavity. So we've gone through the blood flow through the heart, the valves, the vessels and the chambers. So you should be able to describe the drop of blood, trace it from when it returns from your neck or head. It would come through the superior vena cava. If it's coming from anything below the diaphragm, it would return through the inferior vena cava. Then just trace it through the right atrium, right ventricle, off to the lungs, through the appropriate vessels. From the lungs, it comes back to the left atrium, left ventricle, gets pumped back out to the aorta to the rest of the body. So let's do the valves, and then we can identify a few of these other blood vessels. Let me go ahead and number these things before I forget. So what we're going to do, we're going to come back and number or identify this, which will be 1, and then this will be 2. This will be our third branch off of the aortic arch. So you'll need to identify those in order. We'll go through those in a minute. And then number 1, branches. So let's identify number 4 and number 5. This pattern, this picture here, you should learn. You need to identify those blood vessels off of the aortic arch. They're on models. I believe they're shown on the learner models as well. So let's do the valves. So we're up to, what's wrong with that picture? I have 2 5s or 2 4s. Let's make that one 5 like it should have been. So 5 vessels that you need to identify off of the arch. And then let's do the valves. So let's do 6 will be this valve, and then 7 will be that valve. So number 6 is entering the ventricle. Number 7 is leaving the ventricle. And then let's do this in order of blood flow. So we'll do 8, because it's coming back to the left ventricle. The last valve that blood flows through is 9. So let's go ahead and identify 1 through 9. So number 1 is the Brachiocephalic Artery. It's sometimes referred to as the brachiocephalic trunk, but if you called it a trunk, you would need to put an A after it indicating artery, because there are 2 brachiocephalic veins that we're not doing yet. So number 1 is the brachiocephalic artery, and then number 2 is the left, I'm abbreviating left, common carotid artery. And I'm just going to use A for arteries throughout. And then 3, the last one off of the arch, is the left subclavian artery. Four and 5 branch from the brachiocephalic artery. So number 4 is the left common carotid artery. And number 5 is the, number 4 is on the right side. I need to back up, find my little tiny eraser, and get rid of the L for number 4. We're on the right side of the head. Should have caught that. This is the right common carotid. So what we have going here is 1 and 2 are delivering blood to the head. So this is sort of a midline, if you will. And this would be left side of head. Oops. And this would be the right side of head. So number 2 is carrying blood up through the left common carotid up into the head. So it's coming right up this side on the left side, coming off the arch and going straight up into the head. On the other side, for the right side, the blood comes off the arch, goes through the brachiocephalic trunk, and then goes up through the right common carotid artery. So you have a left and a right, and they're both going up to supply both sides of the head. That's the picture. Number 5 is the right subclavian artery. So the subclavian arteries go right underneath the clavicle, subclavian, and then they go out to the arms. So the right subclavian goes out to the clavicle, passes through the axillary region and off to the arm, same with the left side. So what we've done with these branches off the arch is we've supplied the head, neck, and the upper extremities, right and left arms. So the vessel coming off the arch going to the left arm would be the left subclavian. If we're going to the right arm, we would go off through number 5, the right subclavian. 2 and 4 carry blood up to the head. That's the idea. So that completes the vessels. Let's do the valves. And number 6 is the first valve that blood passes through when it returns to the heart. So blood comes through the right atrium into the right ventricle, and it passes through the right atrioventricular valve. No significance to color change here. So 6 is the right atrioventricular valve. This is also sometimes referred to as the tricuspid valve. That's the first one. Atrio for atria, ventricular for ventricles, the atrioventricular valve. Number 7 is the pulmonic valve. You could call it pulmonic, you could call it pulmonary valve. They are sometimes referred to as semilunar valves. Semilunar. But if you refer to it as the semilunar valve, you need to specify whether it's the right or the left. And this would be the right semilunar valve. I would probably just go with pulmonic or pulmonary valve because it's between the right ventricle and the pulmonary circulation. Number 8 is the third valve, and that is the left atrioventricular valve. Let me give some other abbreviations for it first. It's the left atrioventricular valve, or you could refer to it as the bicuspid valve, and the tricuspid on the right, the bicuspid is on the left. I'm going to change this for your notes, so bear with me, it's not a big deal. Left atrioventricular valve also equals the bicuspid, which is also the same name or the same thing as the mitral valve. You can call that valve any one of those three, but you need to know all three. So if I refer to the mitral valve, you know that it's the same as the bicuspid or the left atrioventricular valve. And the last valve is the aortic valve. This is also sometimes referred to as the left semilunar valve. And then one other thing that I put in this drawing is over here, check this out. I'm just going to put an asterisk by these two little nubs that are coming off of the ascending aorta. So those two little nubs, those two star asterisks that I just wrote on the map, are referring to those tiny little vessels. And if you look carefully, I drew them intentionally, is that they are directly behind the flaps of the aortic valve. So that's a little darker, a little easier to see perhaps. Oops, forget that line that just appeared. But those are the beginning, the openings to the right and left coronary arteries. Okay, so there's a fair amount there. What I want you to practice is tracing the drop of blood through the heart, from returning to the right atrium to heading out to, let's say, the left arm. And you would need to trace it through the chambers, the vessels, the lungs, and the valves, and then off to the target, whatever that is. Let's say it's the left arm. Okay, so that's going to take some practice. Let's move on. Computer makes me nervous when I get the spinning clock like that. Well, okay, just rebooted. You shouldn't lose anything since the recorder is recording what's on the screen. We just have this awkward pause in the middle. Okay, I don't know what that was about, but it just sort of crashed. I'm glad it wasn't fatal. So this slide shows two fetal pulmonary bypasses. So this is the fetus in the uterus during development. Its lungs are non-functional. The lungs are collapsed. So most of the blood bypasses the lungs. In the adult circulation, or postnatal circulation after birth, the lungs have to be functioning. So after birth, 100% of the cardiac output flows through the lungs. So if the heart is beating 5 liters per minute, blood flow through the lungs is 5 liters a minute. So 100% of the blood leaving the right ventricle goes through the lungs and it goes back to the left side of the heart. In utero, while the fetus is developing, though, the lungs are collapsed. And there's just too much resistance to push all that blood through the lungs. They're non-functioning anyways. The pulmonary circuit normally is low pressure. So in the fetus, there are two pulmonary bypasses where most of the blood bypasses the lungs. So that's what we're talking about. So this is in the fetal circulation only. The first one is the Foramen Ovale. So blood that has returned to the right, I'm going to use yellow, to the right atrium through the superior and inferior vena cava. You can identify those. It would normally flow, and some of it still does, into the right ventricle, where it will then be pumped out through the pulmonary valve into the pulmonary trunk. But one of these bypasses is the Foramen Ovale, and it is between the right and left atrium. So the blood passes through this little foramen, through that hole. It just bypassed the right side of the heart. It entered the right atrium, but it just bypassed the right ventricle. So that blood is not going to the lungs. This blood will then just continue on down into the left ventricle and then be pumped out through the aorta to the rest of the fetal circulation. So that's the first of these two bypasses. And by the way, when you see the word patent, so this is a patent foramen ovale. Patent means that it's open. And normally after adult or after birth, that foramen ovale closes. It works. There are two flaps there between the atria within the interatrial septum, and the blood passes through between those two flaps. After birth, the pressure changes in the atria and the flaps close, and then the blood can't go through it. That's how it's normally supposed to happen or work. If the flaps don't close and blood can still leak through that foramen ovale, then it's said to be patent. And after birth, that's a problem. Before birth, in utero, that's what you want, is to have that valve, that foramen open. So that's the foramen ovale. So practice tracing that and describing the blood flow. The other pulmonary bypass is the Ductus Arteriosus. Again, the idea is to shunt blood away from the lungs. So normally blood is flowing out of the left ventricle into the aorta and going off to all the places that it goes. That's all fine and good. Goes down the descending aorta. So that's out of the left side, but again, some of this blood from the right side needs to bypass the lungs. So this is blood that's coming up out of the right ventricle. It did not get diverted at the foramen ovale. It went into the right ventricle. And now instead of going off to the lungs, instead, those are basically blocked off. They're collapsed. And the blood then flows out through this ductus arteriosus into the aorta. So that's the ductus arteriosus. It is this little piece of vessel that connects the pulmonary artery or the pulmonary trunk to the aorta. So it's bypassing the lungs. Instead of going to the lungs, it goes to the aorta. Okay? So practice that also. Let's talk about the pericardial membranes, and that'll be the last for this section. So these are membranes that are around the heart. The heart is beating inside a fluid-filled bag. There's not a lot of fluid in the sac, in the pericardial sac, but there's enough to keep it lubricated. The walls are very slippery, so to reduce friction. So the pericardial membranes, there are 3 of them. And I'm just going to list them here, and then we'll come back and look at them in detail. So what we're looking at is the wall of the heart here, which is what's highlighted in the figure above. So the endocardium is the muscle of the heart. Excuse me, the myocardium is the muscle that's pumping. The endocardium is an epithelial membrane, referred to in this case as the endocardium, but it's continuous with the epithelium. Excuse me, endothelium. And the endothelium, you recall, is what lines the blood vessels. So the endocardium is the membrane that's lining the lumen of the heart. Myocardium is the muscle, but the pericardial membranes are shown over here, and we'll do them. Well, here's one. This is the visceral layer of the serous pericardium. So we're going to talk about serous in a minute. And then there's the parietal layer of the serous pericardium. So we have a visceral layer and a parietal layer. And then we have a fibrous pericardium. So there are the three that we'll talk about. So in order, attached to the outer surface of the heart here is the visceral layer of the serous pericardium. This is the pericardial cavity between the two membranes, and it's filled with pericardial fluid. Not a lot of fluid, maybe a couple of mils total. And then we have the parietal layer and then the fibrous pericardium. So let's go to the next slide, which I think is a review of mucus versus serous. So we're talking about the serous pericardium. So let's just review these two types of epithelial membranes. So we're talking about an epithelium, and you remember that epithelial membranes line surfaces. Well, if it's a mucous membrane, those surfaces open to the outside of the body. So for example, your oral cavity is lined with oral mucosa. That's a mucous membrane. You can go down the esophagus. The lining of the esophagus is a mucous membrane, as is the lining that on the inside of the lumen of the stomach. Those all open to the outside, more or less. Same with the lumen of the lungs. When you inhale air, it's flowing past a mucous membrane on those respiratory passages. Serous membranes, on the other hand, are still epithelial. They're still lining a surface, but these surfaces do not open to the outside of the body. So pericardial membranes, these are on the outside of the heart. They don't open to the outside of the body, obviously. The outer lining of your stomach, the outer lining of the intestines and the lungs, etc., those are all serous membranes. Okay, so that's just a quick little review of mucous versus serous membranes. Here is another picture of this idea of the two serous pericardial membranes, and the fibrous one is not shown. So I'm doing these in order. So we have the visceral serous pericardium and the parietal. General terms, visceral and parietal. Visceral refers to the organ, the tissue, the viscera, the guts, crudely speaking. And the parietal membrane is referring to the outer perimeter, if you will. So the visceral serous pericardium, it's a serous membrane, and it lines the viscera. It's aligning the heart. The parietal serous pericardium is peripheral to that and is out here. So that's the order. And between the two is the pericardial cavity again. And the pericardial cavity has fluid. And this illustration over on the left shows sort of an analogy of taking your fist and pushing it into an underinflated balloon. And the balloon sort of wraps around the fist as you push it in. And that's what they're showing over here. Similar to how the development of the pericardial membranes work. So you should be able to identify these two membranes. Okay? Next slide is the third pericardial membrane, which is the fibrous pericardium. This is the outermost layer. So the fibrous pericardium is this tissue out here. And that doesn't show up very well. Let's go to green. So this is very tough, fibrous connective tissue that attaches the heart to, what's the structure immediately below in that diagram? What is this? It's what the heart is sitting on. That's the diaphragm. And the fibrous pericardium attaches to the diaphragm, wraps all the way around the heart, anchors it to the blood vessels, pulmonary trunk, anchors it in part to the mediastinal wall. What's important about the fibrous pericardium is that it is inelastic. It does not stretch. Okay? So it anchors the heart to the diaphragm within the mediastinum. And if, here it is on the right side, let's just finish off the figure, and it's just shown as the dark purple line. It's inelastic all the way around. Okay, so if fluid leaks into that space, let me back up a minute to the previous slide. So if we have fluid, let's say excess fluid, that goes with the next slide, but if we have that, it's building up in there, and you remember that the fibrous pericardium doesn't stretch, and as fluid builds up in there, the heart cannot expand, and if it can't expand, it can't fill with blood. During contraction, it contracts and squeezes the blood out, and the volume of the heart gets smaller. And then to fill, it has to relax and expand. So it's constantly contracting and expanding. And if that pericardial space fills with fluid, when it contracts, there's excess fluid building up in that pericardial space, but then the heart can't expand as much. So it can't pump as much. And if fluid continues to flow or leak into that pericardial space, it basically compresses the heart more and more. And then it can't fill with blood, and if it can't fill with blood, it can't pump blood, and that's a problem. So the venous return would go down, and cardiac output would go down. And that creates this condition called cardiac tamponade. And I would like you to read about that in OpenStax in your textbook. So you can just type cardiac tamponade into the little hourglass search feature. When you're viewing the book on Learner, you can do this. So open up Learner, click on the Learn tab, and that will open up the book, and then find the little magnifying glass icon for search, click that, type in cardiac tamponade or whatever else you want, and that will take you to that discussion in the book. And you can click to either go to the next place where that term is found or the previous. So play around with that, because I'm going to make reference to that several times. Okay. So that's it for the heart. Structures, valves, vessels, and pericardial membranes. This is important. Please practice it and ask questions. So get out some scratch paper and see what you can do for drawing and explaining it to your housemates or your family or whoever you're with, or your dog or your cat, if that's who you're with. Okay, bye. See you next time.